after the session. So my name is Khayyam Siddiqui. I head up the big data platform at Citi for Treasury and Trade Solutions, which is a division within Citi. Citi is a huge organization. I'll give you a quick overview of what my division does in Citi, and then really lead on to the use case in terms of how we used CR8 to really enable streaming and really a real-time use case for us based on our tech stack and based on sort of our huge inventory and ecosystem of existing sort of legacy databases. So we'll get a bit into that. So TTS is a global business. We're part of what's called an institutional client group. So you have within Citi, you probably have seen the retail branches, that's the consumer side. And then there's an institutional side for sort of corporate businesses. So this is really for corporate multinational companies, for other financial institutions. We operate in 160 countries. We're in 98 and we do business in 160 countries worldwide, primarily for cash management. So you're talking about making payments, receiving payments, doing liquidity management, commercial credit cards, doing working capital, those kind of services. So if you think of something like, and we have most of the Fortune 500 global clients, so Google, your Amazons, Uber. If you think about Uber drivers, when Uber has to pay them, they go through the Citi network, in essence. So they come, in a part, you'll see the use case that we're talking about in terms of our big data implementation, and then how we use CR8 to enable some of that work to be done. So that's a quick high level of what we do in the TTS area. And we'll talk a bit about now getting into the use case. So for us, payments is a very large part of our business in terms of making payments to people, for organizations, to both customers and third parties. So when you make a payment, if you think about a payment in a traditional sense, it can actually be quite a complex process, given cross-border environments, different countries, different regulations, different types of payments. So within the US, you might have heard of ACH payments, we do wire transfers. If you go into the European Union, you have a different type of payment system called SEPA payments. There's different types of payments. There's low-value payments, high-value payments. So with all that, what would typically happen is a customer, sort of a corporate client, would put in a batch of payments. They have a portal to do that. That payment would then go off through this life cycle of payment. It would get validated. There would be a credit check, there would be a balance check. There's sanctions checks involved to make sure that you're not, a bad person. The beneficiary, the person you're sending that payment to, isn't on some government checklist. So there's a whole slew of processes that happen for that payment, and then for the end payment to actually be sent outside of Citi for clearing, gets cleared, gets deposited in the final beneficiary bank account, right? So that, if that payment was initiated, it would be received, but from a Citi portal perspective, for that person to see it, they would only see that payment once it's been processed and it's been processed by the beneficiary bank and they've received it. If something happened to that payment in between, like if any of these issues occurred, or they were on a sanctions list, or they didn't have funds, they would have to ring up. They would have to call up the service center, and it could take anywhere from between an hour for a happy use case where they would know they'd be able to track the payment, whereas a more complex payment that's going to a foreign country, maybe somewhere in Azerbaijan, you could take up to 48 hours to get your status back on where your payment is. Right? So that was a big problem from a business perspective that we had to solve. And now the problem that we have is that Citi, like most banks and most financial institutions, they've grown organically, they've acquired other companies. So you have other systems, legacy databases, vendor products, regional products, country-based, regional-based, and then global-based. They all operate in different technologies, right? Different technology stacks. So in order for us to do this quickly and rapidly, I think as Michael and David were mentioning, we couldn't re-architect the whole ecosystem. Right? So we couldn't go in and say, okay, we're going to have a standardized database and a standardized connectors across the whole sort of payments process flow. So in essence, what we have to say is, okay, we'll use the existing databases we have, and then let's see how we can read that data, be able to replicate that data in real time, put it into a standardized, put it into a standardized format that everyone understands. So in this sense, what we're talking about here is based on industry formats. There's what's known as a CAMT52, which is an industry format of an account and a payment. We wanted to standardize what a payment looks like, because what will happen is you go to one payment system versus another payment system, and there within their databases, obviously the idea of a payment is totally different. They'll have a totally physical architecture, even a logical architecture will be different. So we wanted to standardize what a payment looks like, and once we've done that, we then have a common form of a target, of what target looks like. So we can now replicate and transform in real time, near real time, transform to a common standard format, and then present that format downstream to wherever the consumers are. So in this case, you can see there's a portal. So that was the idea, and that was the vision in terms of what we wanted to do in terms of the business problem that we wanted to achieve. So from a business perspective, it was really clients and customers wanted to see everything real time as possible, get their information, have a globally consistent view across all countries, across all boundaries, regions, whether you're in Europe, whether you're in Asia, whether you're in Latin America, and then have a standardized way of presenting that information to them. Right? So that was kind of the aim of what we had to do. So to meet that, what we did, we had to think a bit outside the box, and this is we kind of collided into DBS-H actually. We were going down this path of CDC using change data capture to really expose and unbundle our traditional database, right? Because we wanted to take it out of those monolithic databases, because we've got very different types of databases. Being Citi, we've got a huge legacy platform set. So you've got your Oracles, we've got Hbase, we've got SQL Server, we've got DB2 on AIX, we've got DB2 on mainframe. We've even got some Fox Pro apparently still running around. So there's very many different types of databases. Right? So the whole point here was let's unbundle that database. So we looked at replication technologies. We did a whole sort of pilot case study around that. And then we met DBS-H and walked through their solution. And what was really appealing was the fact that we didn't have to, we couldn't be intrusive, because a lot of these are in-country systems. We don't have the mandate to go out and actually change them or impose agents on their servers, etc. So the whole point here was that CR8 runs remotely. It doesn't run on the actual database or your source system. So we're able to run this remotely. It could be in a VM, it could be on physical hardware. And it's non-intrusive in that sense. It's really just reading the redo logs, the archive logs from the underlying database. So we were able to set out a design, an architecture using CR8 as our CDC tool, and really then designing a pipeline downstream. So once I've got CR8, the good thing with CR8 is, as you've seen, there's many different targets. So for us, what made sense was we didn't want to replicate one-to-one, given the fact that we had to standardize. We have many different types of payment databases and applications, and we wanted to standardize in a common format. So what really made sense for us was to use Kafka. Kafka to standardize and then process after we've received the core database events. So CR8 is great in sending you those events to Kafka. And then once you've got them in Kafka gives you you then have that flexibility to do what you want with it. So then you can process that data, standardize that data, enrich it, and then push it downstream. So that's basically what we ended up doing. So this diagram may be a bit, I don't know if it's hard to read, but I'll quickly walk through from left to right. So source systems wide, we have on the left-hand side, you see all these are all the kind of legacy databases. You've got your Oracles, you've got your Hbases, SQL servers. And essentially CR8 is now listening to those, it's using a JDBC connection, it's listening to those reading logs, it's listening to those archive logs, it's picking up all those database events in real time, pushing it to Kafka. Once it comes to Kafka, what we've done is we have different topics set up for different source databases. And from there, we have basically, we're using Spark streaming. So Spark streaming is then essentially doing the sort of core ETL, if you will, but in a real time, on a real time, batch windowed basis, right? So it's basically splitting up micro batches. But in essence, we're able to take that data, transform it using Spark streaming. We then push it into Hbase. So Michael again, mentioned Hbase. So we use Hbase as a target. We do further manipulation within Hbase as well. And then what we do is, at the same time as we do that, once that's done, we also put it into, we have a caching layer, because remember, this has to be used by clients pretty much on an online portal in real time. So the idea here is that while Hbase is very good for processing the data and doing large volumes of processing and storing that data, we needed certain flexibility, as was mentioned. Hbase is a single row key-based database. You can't do, if a customer comes in and he wants to do a slice and dice or a sort on his payments, look up the value date, look up different information, filter that data, that's hard to achieve in Hbase. So what we're using is really a version of Apache Ignite, which is an in-memory distributed cache. Vendor supported, the product is actually called Khayyam, and we're using that to keep the core payments then in memory. And then those are being exposed through an API. So we have a RESTful API service layer that then talks to our enterprise portal, Citi Direct, which is then used, it's our customer-facing portal where queries and these queries and searches come in, and then we're able to satisfy those through the API. So at a high level, that's kind of the flow. So we use CR8 in a real-time ingestion mode from all these legacy databases, split throughout the world, and then they come into our cluster, into our Hadoop cluster, where we're running Kafka, and then from Kafka we Spark Stream, do ETL, enrich the data set, pass it down, push it down to Hbase, push it into the cache, and then it's available for end users. So that's kind of a high level of the architecture of how we're using CR8 to really give us that real-time streaming capability for a lot of these legacy databases, and to really unify our payments, right, as we push out the payments and are able to give that insight back to our clients and customers. So in terms of some considerations, we went along this journey with DBS-H in terms of how we structured this and did this. So, and I think Michael touched upon some of this in his learnings as well. But really, you have to use Kafka partitioning to your kind of strengths. It's really a key factor in giving you parallelism. We had a set number of partitions that were created. We used a hash partition key to randomly distribute between those partitions to give us parallelism and throughput. We were using just regular Spark streaming, so basically based on the dstream API, so it's micro-batching. It's micro-batching those events. And we're now enhancing that with some of the new features in structured streaming that come out this year, so that you get more of an unbounded view of the stream, and you depend on the end of the stream. So there's some changes we're making to that. But right now, it basically operates as a micro-batch based on a time window, and then it takes that data set and is able to stream that, make operations on it, enrich that data. So what we're doing, what we're essentially doing is, if you think about payment, we're standardizing things like the payment status. So has the payment status been received? Has it been acknowledged? Has it gone through validation? Has it gone through sanctions check? All the different systems give us different values, and we standardize that into an ISO international standards-based enrichment. So we standardize those, we enrich certain fields, etc. And then we push that down into Hbase. In Hbase, I think, as Michael mentioned, from a time dimension, from a time stack dimension, once you put into Hbase, it goes on a millisecond timestamp, is based on a millisecond. Now, when you're getting millions of events coming in, that can be a problem, right? The other part is, if you think about this problem, what you're doing is you're taking stateful events from a database, and you're putting them through sort of what wants to be a stateless process from a streaming perspective, right? So you can have out-of-order events coming through. So the way we handled that was to, in CR8, what happens is when you get that JSON message, it actually includes the command SCN. So that's in Oracle. If you're familiar with Oracle, the SCN is the unique way to identify each and every transaction record event within the database. So we use that command SCN that's passed on from the message, and then we use that to actually push down into Hbase, replacing the timestamp. So now everything is ordered by your SCN. So events can come in out of order from a streaming perspective, but now Hbase is automatically ordering that by the SCN, so everything's in order in terms of updates and inserts. So that takes care of really making sure that your ordering is correct on the target, even though you put it through sort of a streaming process, and you're getting stateful transactions from the source. took care of that. There's other factors in terms of just tweaking the way your batches operate, how many dynamic executors you have within Spark. Spark has a lot of a lot of parameters and variables there that you have to kind of fine tune in terms of performance of the batch and how it operates. From a Kafka perspective, the offsets and being able to replay events is kind of key for us in having a repeatable process. So if we have an error in a payment or we have an issue, we can replay that individual payment based on the offset. We have an offset tracker that we keep. So we've tried to make this sort of resilient as possible. The actual, from a Kafka perspective, everything, you have a leader and follower which elects which partitions you use, so that's all backed up. And then within Hbase, you have our concept of region servers, which are also multi-replicated throughout the cluster. So we ensure that we have resiliency from that perspective. So those were some of the learnings, but that's kind of a high-level architecture of our use case of how we implemented using CR8, and we were able to basically take those legacy databases and take that information and consolidate and present back to our users in real time. So we're currently running, we have about 50 plus source databases that are being read by CR8 in real time. Roughly on average, we're processing around 2 million database events in an hour on any one of our topics. And then that's being processed in real time through streaming to Hbase and cache. And I think that was it.